Welcome to this explainer. Today, we're looking at the GATE 2021 challenge, Decoding the Fractional Anomaly. Picture this. You're sitting in a dimly lit examination hall. The silence is heavy, broken only by the frantic scratching of pens and the relentless ticking of the clock. You're facing a literal boss battle, a one-mark question from the GATE 2021 computer science exam. And look, in the world of competitive engineering, one mark is never just a mark, right? It's the absolute difference between getting into your dream institute and having to try all over again next year. So let's jump right in and conquer this deep, intense analysis together. Okay, let's dive into this. The problem asks, if the binary sequence 0.1101 equals the decimal number 0.8xy5, what is the value of x plus y? Honestly, it feels a bit like an encrypted cipher, doesn't it? I mean, we're all super comfortable with whole integers. Give any engineer a binary like 1010, and they'll instantly shout 10 without missing a beat. But throw a decimal point in there, and suddenly we're forced to bridge two completely different realities. On one hand, you've got the base 2 electric reality of machines, and on the other, the base 10 reality of humans. Our mission right now is to decode this fractional binary string and expose those unknown digits x and y.
To defeat this boss, we've got to summon its fundamental components. You know the golden rule. In any number system, a digit's power comes entirely from its position. And the moment you cross that binary point, you're stepping into the realm of negative powers. So let's lay out the mechanics here. That first bit is a 1, and it carries a weight of 2 to the power of minus 1. The second bit, another 1, is weight at 2 to the minus 2. Then the third bit is a 0, weight at 2 to the minus 3. And finally, that last bit is a 1, with a weight of 2 to the minus 4. Remember, these aren't just abstract numbers floating in space. They are actual concrete fractions of reality. We're talking 0.5, 0.25, 0.125, and 0.0625. Just like that, we've stripped this binary anomaly of its mystery. And this brilliantly illustrates the sheer, satisfying logic of numerical synthesis. We've got our decimal pieces ready to go: 0.5, 0.25, and 0.0625. Now, you might be wondering, hey, why did we just bypass the 0.125? Well, that's because its corresponding binary bit was a 0. It's essentially deactivated. So imagine doing this mental math without a calculator. In that high-pressure exam hall, you stack them up. 0.5 plus 0.25 gives you 0.75. Then you carefully add that final tiny piece, the 0.0625. The gears turn and the final value locks perfectly into place with a satisfying crunch. 0.8125. The alchemical translation is completely done. We have literally pulled machine code directly into our human decimal domain.
Okay, so the heavy lifting is done, but the battle, it isn't over just yet. We need to align our hard-earned truth with the original blueprint the exam threw at us. So we're matching 0.8125 against 0.8xy5. This is exactly like DNA's sequencing. Look at it. The 0 matches the 0, the decimal point matches perfectly, the 8 aligns with the 8, and that 5 at the very tail end aligns seamlessly with the 5. In that brilliant, satisfying moment of alignment, the variables literally have nowhere left to hide. The x, sitting right there in the second decimal place, is unequivocally the number 1, and the y, hanging out in the third decimal place, is exactly 2. So we've got x equals 1 and y equals 2. You can probably feel that rush of adrenaline right now. You want to immediately write down 1 and 2 and just sprint to the next question. But wait, stop right there, take a breath. In the incredibly high-stakes environment of GATE, this exact moment, it's a psychological trap. It is a pitfall specifically designed by the examiners to catch the hasty student. If you just input 1 or 2, all of your flawless calculations turn into a devastating 0, because this boss battle demands a final strike. The question doesn't just want x and y, it demands the unified combined value of x plus y. And so, with a single, decisive motion, 1 plus 2 equals 3, boom. That is the final blow. That is exactly how you secure your mark. What initially looked like this terrifying fractional glitch floating in the digital void was, in reality, just a test of your absolute fundamentals. Think about what we just did. We broke the binary down to its roots, we synthesized the fractions, matched the pattern, and completely sidestepped their psychological trap. We didn't just solve a number system problem today, we completely dismantled it. The final answer is unequivocally 3. Before we wrap up, remember something absolutely crucial. Mastering these fundamental conversions isn't just about scoring a single mark on an exam. It's really about building that deep architectural understanding that literally everything in computer science relies upon. Every single floating point operation, every complex algorithm, they all trace their roots back to these incredibly simple binary foundations. When you truly understand the math at this granular level, you gain the power to build and manipulate the digital world. So keep your fundamentals sharp, keep decoding those anomalies, and ask yourself, what puzzle will you conquer next? I'll see you in our next explainer.